colored pens up. Today's warm-up is a straight review of the last lesson. You were introduced to compound inequalities. Let's see how we're doing so far. Number one, what did you get? We'll start with Dalton, Chris, and then Nathaniel.
X is less than -4 or x is greater than -1.
Okay, Chris?
X is less than -4, x is greater than equal to -1.
Okay, it sounded slightly different. Go ahead, Nathaniel.
X is less than -4, x is greater than equal to
So, x is less than -4, or x is greater than or equal to -1. Okay. Would you have it written down? Good. Kayla, you had a comment about that? Yes, in a moment. Number two, what did we get? We'll start with Kayla over here, Kadir, Sebastian, and then Edgar. Go ahead, Kayla. Okay, Kadir, what did you get?
X is greater than -1 and x is less than 3.
Okay, what did you get?
X is less than 3 and greater than -1.
Okay, so you have the same numbers, but that's a different statement. What did you get, Edgar? Okay, so I think that's what the other two people said. So here is what I was looking for. X is greater than -1 and less than 3. Now, there are probably, if I had to guess based on my extensive experience, a lot of you have this. If you have that, then that means you did everything correct. You just missed one thing that I've been talking about for several days. So what's the issue with this? Kadir?
Small numbers should be on the left and bigger numbers should be
Yeah. So even though these two statements are really the same thing, this doesn't make sense because I want you to watch what happens when I graph it. Look at what it looks like. Does that make sense? Maybe it makes sense. I don't know. Does that make sense? Where I put the numbers? What's wrong with where I put the numbers? Because I modeled this. I took the 3, it was over here, I put it right there. I took the -1, I put it right there. What's the problem? Fung, what's the problem? What's supposed to be on the left? Negative supposed to be on the left. Okay. Kalasia, can you continue your thought?
It's only because of negative before positive.
Comes before a positive? What do you mean? Okay, I think I know what you mean, Janae.
the smallest number supposed to be on.
That's really the best way to say it. I know that's what you were both trying to say, but the smaller number is supposed to be on the left. This number shouldn't be here. It's supposed to be over here somewhere. So this absolutely makes no sense whatsoever. So since this doesn't make sense, writing it like this doesn't make sense. This is the answer that we're looking for. Comments or questions about any of this? Concerns? Issues? Okay. Today we're going to be exploring the idea of an absolute value equation. All of chapter 6 is about inequalities. So I wrapped 6.1, 0.2, and 0.3 all into one lesson, but they were all about inequalities. And then 6.4, which we just finished, was also about inequalities. And guess what? The rest of the chapter is all about inequalities. But now all of a sudden we're going to talk about equations again. There's a very important reason. You're not going to quite understand the reason until I do the next lesson. Then it will become clear to you why I did this lesson. But the good news is we're going to be going back to equations for a little while. But we're going to be exploring equations that you've never seen before. So, first of all, absolute value equations. We have to review the idea of an absolute value. And although I'm pretty sure that most of you could tell me what an absolute value is, it's a very difficult idea to really get straight in your mind. That's for kids and adults. Absolute value is a distance. So we're talking about distances. And here's the funny thing about distances, is that distances can never be negative. You might have already known that also because last year your teacher was pretty good. Here's the idea. If you drove up to Orlando during the long weekend and you had been driving for an hour and you were getting tired and you asked your parent how much further you had to go, Dad, how much further is it to Orlando? Your parent would never say, oh, we have negative 120 miles to go. And then when you're at Orlando and you're wrapping up the trip and you have to get the car ready and you're going to go home, even though you're going back home, if you ask your parent how far is the trip back home, they would never say, oh, it's negative 300 miles. They would tell you it's 300 miles. Because there's no such thing as a negative distance. It doesn't make any sense. And so you have to keep that idea in your mind. That when you talk about distance, it can never be negative. That's going to play a strong role in today's lesson. Now, I'm going to let the cat out of the bag right up front. That every absolute value equation has two solutions. So, let me back up again for a second. We studied equations and we solved equations all through chapter 3. If we look across the top, with the exception of the last poster, every one of those equations has one solution. Everything up there has one solution. Then we started studying inequalities, and what you've learned over the last week and a half is that inequalities have many solutions. That's why we graph them on a number line, because there's so many solutions that we can't list them. It becomes impractical to list them, so we draw a picture of it. That's why we do that. And I already went over that with you. Now we're kind of going in between. It's not one solution and it's not many, many solutions. It's now two solutions. Every absolute value equation has two solutions. And I'm going to give you two explanations as to why. Here's the first explanation. Let's start on the left. So we're over here. Everybody here should know that the absolute value of 8 is 8. But what you may not realize, and maybe you did not internalize from last year, is that what this really says is the distance, that's what this really says, the distance of 8 from 0 is 8 units. When you have an absolute value, the number on the right is really a distance. This is telling us how many units this is from 0. So look at the one in the middle. How many units is this number from 0? It's a distance of 8 units away. Remember, absolute value is a distance. Distance can never be negative, and that's why these two numbers are positive numbers, because they represent distances. So now look at the third equation here. Now we're shifting into a higher level. This is 6th grade material, pre-algebra material. But now I'm asking, what numbers could go here so that its distance was 8 units? What number could go here so that the distance was 8 units? So can you give me the number that would make that work? I got 7 people who can give me the number. 8, 9 people. Matthew? 8. If I put an 8 right here, then that will make this a true statement, which is the same thing as over here. But is 8 the only possibility?
No.
Isn't? Oh, we got a resounding no. Is there another? What's the other possibility then? I had a lot of people over here say no. What's the other possibility, Alexandra? Yeah, because I just showed you right here that the distance of -8 from 0 is also 8. So I can also put a -8 right there. And so x can equal 2 different numbers. 2 solutions. 8 and -8. So that's one explanation as to why there are 2 solutions. Does anyone have any questions so far? You may have no idea what I'm talking about yet, but it will start to become more clear as we work through this. Here's the second explanation, and I have to go to the second page and then I'm going to come back to this one. Is we need to look at it graphically. So here is, and you don't need to draw this, you need to put your pencils down and watch. This is a graph of a linear equation. In fact, it's a graph of the most basic linear equation there is. Y equals x. Every point on the line is a solution. And the solution is an ordered pair. And this solution that I just drew in is 5, 5. There is no other solution that will have the same numbers in it. There's many, many solutions along the line. I could pick any of these points. I could pick this one, that one, this down here. These are all solutions to this. But every y value has one x value. It has one partner. But I want you to look at what happens with an absolute value graph. That's the graph of y equals the absolute value of x. So what observations can you make about this graph compared to that one? What things can you say are similar? What's different? What could you say? Davis, Matthew, Dalton, Kadir, what could you say?
Well, in the bottom graph, there are no negatives whatsoever for the ends of the line. There are no negative lines. For the
Yeah.
top, there are negatives.
Yeah, that's a huge observation he just made. Look down here. There are no y values that are less than 0. But in this case, there are y values less than 0. For example, if you're not sure what he's talking about, the coordinates of this right here are -5, -5. That y value right there is a negative number. There are no points on this line that would have a negative y value. Very good observation. Matthew, what else? It's a what?
A right angle.
Are you sure? Yeah, well, I'm not sure if you know why it's a right angle, but you happen to be correct. This is a right angle. Is there another name for these two lines here? Is there another name that indicates the same thing he just said? That you already learned in my class? Valerie? Yeah, these two lines are perpendicular. They're perpendicular lines. Now this is really one graph, so it's not really two lines, but it does form a right angle right there. Very good observation. Dalton?
Both x values positive and
There's positive and negative x values. Very good. Very important observation. Kadir and then Fung? Okay, very good. It kind of bends at the origin right there. Very good observation. Fung?
in the middle of the line is like distant between one line and the other line can't be negative and like
Okay. I think I understand what you mean. Well, let me put it all together for you because I'm using this to explain why there are two solutions to an absolute value equation. There's two solutions to solving every absolute value equation because look, for the y value of 5, there are two different x values. Look at this point right here and this point right here. The coordinates of this point are 5, 5. The coordinates of this point are -5, 5. The y value is the same. The x values are opposites. So there are two x values for every y value. And that is true going from here all the way up on forever. So that's what you should see is that if I go right here, there's an x value here and an x value there. If I go up to here, there's an x value here and an x value there. So that is one reason why one explanation as to why there's two solutions for every absolute value equation. That's complicated. That's hard to understand. I mean, just understanding this graph was very difficult to understand. We spent 2.5 chapters understanding this. Now I'm doing this. Okay? So, let's get to some more practical matters. How can I solve an absolute value equation? How do I find two solutions? So here's the process that I've outlined for you. The first thing we're going to do is something that we've never done before, but it's very similar to something else we've done. We're going to isolate the absolute value on one side of the equation. Number 2, step 2, is where things get totally wacky. And we've never done anything like this, and it's really a trick. It's a shortcut. We take our equation and we rewrite it as two equations. And the answer to one of them is going to be positive, the answer to the other one is going to be negative. And we drop the absolute value symbol. Then we solve both equations, and that's how we get two solutions. So again, it's a 3-step process, but each step has some things that we have to do in it. Number 1, isolating something. We already know how to do that. We are actually experts at that. Step 2, rewriting as two equations. Once you see it done, it won't be difficult for you. Solving both equations is the same thing as solving one. You just have to solve two of them. So this idea goes back to the whole point of that map on the back wall, which unfortunately I never updated into Chapter 6. But Chapter 6 is now using concepts from Chapter 3 and Chapter 4. So everything relates back to things we've done already. Today is a case where we're going to start with the most difficult and work our way towards the less difficult. So we're going to jump right in and do a more challenging question. So the equation we would like to solve is 4 times the absolute value of 2x plus 8 plus 6 equals 30. Now, the absolute value symbol, as you already know, means a distance. But it doesn't mean distance until we isolate it. So the first thing we need to do is isolate the absolute value. So I'm going to draw something for you to help you see what I'm talking about by the word isolate. So we have to isolate that. Here's what you've done in the past. And you do not need to copy this down. 4z plus 6 equals 30. So I want to isolate the z. That's how we solve that. So what would the first step be in solving this? What's the first step? Nathaniel?
Subtract 6 from both sides.
Very good. Subtract 6 from both sides. What would the second step be? Next goal?
Divide both sides.
Very good. So that's it. That will isolate z. So guess what? We're going to do the same thing over here. That will isolate the absolute value. It's the exact same process. So we're going to subtract 6 from both sides. And here's what it's going to look like. Subtract 6 from both sides. This will disappear, which is what we wanted. And then we're left with 4 times the absolute value of 2x plus 8 equals 24. And Extol said, now we divide both sides by 4, and he was right on. Divide by 4. This will now disappear, and now I have isolated the absolute value. Just a little side note, when you draw the absolute value symbol, make sure you draw the line longer than a number 1. There should be a difference between an absolute value symbol and a number 1. So try to make sure that you're drawing your lines a little bit longer. So we've now isolated the absolute value. Now this is a distance. And now we can actually proceed and solve. The way we do this is by rewriting the equation as 2 equations. So here's what it's going to look like. We're going to rewrite, we're going to rewrite this exact same thing, except we drop the absolute value symbol. So we got 2x plus 8 equals 6. That's one equation. Now we're going to write a second one right here. But the only difference will be is instead of the number here being 6, it's going to be a negative 6. So I'm going to write another one. 2x plus 8 equals negative 6. This is a trick. So logically, it doesn't really make that much sense. Like, why would I make that negative 6? Where did that come from? It's a trick that somebody figured out, and I'm now passing on to you. The trick will help us find the 2 solutions to the equation. So now all we have to do is solve each of these. So, solving, how many steps is this going to take, the one I wrote in purple? How many steps is that going to take? Only 3 people can tell me how many steps it's going to take? I should see every single hand up. Every single person knows how many steps it's going to take. How many steps? Sebastian in the back? 2. It's a 2-step equation. Subtract 8 from both sides. This disappears. I get 2x equals negative 2. We don't even need to do anything. We could just figure it out. What will the solution of this one be? Alexandra? Negative 1. So we got one solution as negative 1. Now let's do the green one. Same exact process, subtract 8, subtract 8. The only difference is that we're going to get a different result. Now we get 2x equals negative 14. What's x going to equal here? Chris? Negative 7. So now we think that the solutions are negative 1 and negative 7. So we think we want to say x equals negative 1 and negative 7. But before I circle the answer, let's check and make sure this works. Let's put a negative 1 right here. So everyone, just watch along and do the mental math with me. 2 times negative 1 is what? Kayla? Negative 2. Negative 2 plus 8, what do we get there? Valerie? 6. Now here's the key. Now we take the absolute value of 6. What's the absolute value of 6? Kadir? 6. So now we have 4 times 6 plus 6. 4 times 6 is 24. 24 plus 6 is 30. So we just proved that that one works. Now let's try the negative 7. 2 times negative 7, what do we get there? Dalton? Good. Negative 14 plus 8, what do we get there? Really? We can't do negative 14 plus 8, or we just don't want to participate? Okay, Edgar? Negative 6. But now we take the absolute value of negative 6, and what is the absolute value of negative 6? Nathaniel? No. Well, which is it? Yeah, you got confused. That's okay. Michaela? The 6, because distance is always positive. So the absolute value of negative 6 is also 6. So we end up with 4 times 6 is 24, plus 6 is 30. So we just proved that this works as well. So these are the two solutions to the equation. Does anyone have any questions on how we did that? Go ahead, Caleb.
So you only came up with one answer and you tested it. And the other answer, when you be able to find out the other answer,
I understood the beginning of what you said. I didn't understand the second part. If we found the first answer,
yeah, it was negative. In this case, it was negative 1.
right?
So couldn't we just use negative 1 to find out the absolute number?
No, you can't use this answer to figure out this one, if that's what you're saying. No, you can't use this one to find that one. That won't work. Okay? Ziamara and then Dalton.
I noticed that negative 1 and negative 7 are 6 numbers apart.
Mm-hmm.
In all cases, will that be the same?
Why don't we see? Let's look at the next one and see if that happens as well. Okay? Very interesting observation.
Can you write them separate, or do you have to combine them?
Either way, I'll accept it as x equals negative 1, x equals negative 7, or you can put it with a semicolon between it. The publisher will probably put a comma between it, although I don't really love doing the comma thing. But as long as you got both answers, I will accept it. Okay? Good, so let's go to part B and make sure we're understanding the process. So step one, isolate the absolute value. So what do we have to do to isolate? What do we have to do to isolate this one, Sebastian? Nothing. That was very well said. Nothing. It's already isolated, which means we skip step one and go right to step two where we rewrite it. We rewrite it as two equations. So first, it's going to be exactly the same without the absolute value symbol. So it's x minus 4 equals positive 8. And then we're going to write it again, but this time we're going to turn the answer, the right-hand side, into a negative. X minus 4 equals negative 8. My really high-level students should be able to figure this out without doing anything. You should be able to use mental math or trial and error to figure out what x is going to equal to. So what is one of the solutions going to be? What's the one on the left? Extol? It's 12. Very good. Because 12 minus 4 equals 8. So now that's one of the solutions. What about the one on the right? Sebastian C. What is it? Yeah, it's negative 4, because negative 4 minus 4 is negative 8. So now I'm pretty sure that those are the solutions, but let's check them out and make sure they work. 12 minus 4 is 8, and the absolute value of 8 is 8. Negative 4 minus 4 is negative 8, and the absolute value of negative 8 is 8. So these are the two solutions to the absolute value equation. Yes? Dalton. Okay. So, what do you think? Xiomara, did it work again? Not really, but there still does seem to be some relationship between this number, and that number. But these are not 8 units apart because that's positive 12 and that's negative 4. Yeah, I'm not sure. Maybe there is a connection there. We're going to have to experiment and see. Okay, Michaela?
Is there always going to be two solutions? Or if there's not a solution,
You'll see some special cases as we go along, but we are, in essence, if it's an absolute value equation, we are basically trying to find the two locations on the graph. But what would happen if I put in this number right here? Would I get any solutions? No, because the graph doesn't go down here. Okay? Very good question. All right. Any other comments, questions? Good. We're doing well. Let's see how you do on your own. Checkpoint number 1. Pay attention to your details. You got 2 questions in 3 minutes. See a number of people still working. Go ahead and take 30 seconds to finish up. All right. So colored pens up. Let's see how we did. Part A, what did you get? We will start with, my quiet students, stay on your toes. I'm calling on you one way or another, so you might as well just volunteer. So we'll start with Davis, Danielle, and then Valerie. Davis, what'd you get?
I got x equals 3.6 and x equals 1.
Okay, what'd you get? Part A? Okay, I'll come back to you for B. Valerie? Okay, so we have some disagreement. X equals 11/3 or 3 2/3, and x equals 1. Davis, that's sort of the same thing you said, although I don't know why you converted it to a decimal. You should just leave it as a fraction. You're doing extra work and you're making it less accurate than it is. Because it doesn't equal 3.6. It equals 3.6 repeating. That's different. Okay, but you got to be careful. Okay? You got a comment about that? Or 3 2/3? That's the same thing. I will accept 3 2/3, 3.6 repeating, or 11/3. Part B, what did you get? We'll start with Danielle, Daniela, and then Kalasia. Okay? Okay, what'd you get? X equals 6 and x equals negative 11. Caleb. You got 3 point, I'm sorry, say it again.
For checkpoint A for the first line, I got 3.6 and 7%.
Yes, it is acceptable. But it's unnecessary. Stop converting to decimals. It's not necessary. Just leave it as a fraction. Okay? Comments, questions on either of these? Good hear? Three 2/3. Well, it'll be easier if you plug in 11/3. So let's plug in 11/3 right here. Excuse me. Plug in 11/3 right here. 3 times 11/3 is 11. 11 minus 7 is 4. The absolute value of 4 is 4. 4 plus 5 is 9. Plug in a 1. 3 times 1 is 3. 3 minus 7 is negative 4. The absolute value of negative 4 is 4. 4 plus 5 is 9. Other comments, questions? Okay. Example 2. So we want to solve the absolute value of 7x minus 3 plus 8 equals 5. What's the first step in the outline that I gave you? What's the first step that I taught you? Control? Beautiful. So that's what we need to do. Isolate the absolute value. Subtract 8, subtract 8. This cancels out, and now we've got the absolute value by itself. 7x minus 3 equals negative 3. What's the next step after we isolate the absolute value? What's the next step, Nathaniel? Yeah, make the two equations. Very good. But there's a problem here. Does anyone know what the problem is? What is the problem? Because this is not like the ones we've done so far. There's something different. Chris? Mm-hmm. So? Well, you're definitely onto something. I'm not sure why it's important. It seems like it's important. Jumar? Why is there no solution? Okay, 7x, why can't I put a 0? That'll be perfect. I'll put a 0 right there. 7 times 0 is 0. 0 minus 3 is negative 3, and negative 3 equals negative 3, right? Why can't you do that? We've done equations like that before. I'll come back to you in a minute. Sebastian and then Edgar. What were you going to say, Edgar? Yeah, that's the real explanation. Chris was trying to get that out. He couldn't quite find the words to explain it. But when you have an absolute value all by itself, this number becomes a distance. It only is true if the absolute value is all by itself. So here, this is not a distance because this number is sitting here. But once we got rid of that number, this turned into a distance, and distance will never be negative. So once that negative number pops up, when this is isolated, then we know that Xiomara was correct, that there is no solution. But Xiomara was getting a little confused because she was saying you can't have a 0. Well, you can have a distance of 0. X can be 0. But what she didn't understand is that 0 doesn't work. Because if I put a 0 right here, 7 times 0 is 0, so I get 0 minus 3. 0 minus 3 is negative 3. But what's the absolute value of negative 3? Edgar? 3, not negative 3. The absolute value is positive 3, so 0 does not work. Go ahead, you were trying to say something different? I apologize. Go ahead.
I went ahead and I took off the absolute
Mm-hmm.
and if you take it off, you have to add this 3 to both sides.
Right, but if I gave you this, if I just gave you this on a homework assignment and I asked you to solve it, we can solve that. What do you do to both sides? Add 3, add 3. This cancels, you get 7x equals 0. What's x? X equals 0. Divide both sides by 7, you get x equals 0. So there is a solution to this. But this is not the same thing as this. The absolute value symbol changes the situation completely. Because now, here we're just talking about a number. Here we're talking about distance. It's a completely different situation. So Ziomara, I was with you. I understood what you were saying. But you were confused because you are allowed to have 0 as a solution to an equation. But you can't have 0 as a solution to an equation in this case, because it doesn't work. Now, let's say you got confused, and you didn't pay attention, and you just went ahead and kept going. And you did this. 7x minus 3 equals negative 3, and then you wrote another one like you were taught, 7x minus 3 equals positive 3. And then you solve both of them. The one on the left we just did comes out to x equals 0. The one on the right comes out to x equals 6/7. So we got 2 solutions. So what's the problem? I followed the sequence, I followed the rules, I got 2 solutions, but why am I wrong? Why is it wrong? Okay. All right, but why are these wrong? Why can't these be the solutions? You're right that the distance is negative, and that's messing us up, but I just kind of ignored that, and I just did it anyway, and I got 2 solutions. All right, I got 2 solutions. What's that? They don't work. I already proved to you that the 0 doesn't work. Look what happens when I plug the 6/7 in. If I plug the 6/7 in right here, 7 times 6/7 is 6. 6 minus 3 is 3. The absolute value of 3 is 3. It doesn't work. So you could do this if you really wanted to, and there's going to be students in this room who go home and do their homework tonight, and they're very happy with themselves. They do all this work, and they're going to get the question wrong. And they're not going to realize that they did a whole bunch of work for no reason. I guarantee you it's going to happen to a bunch of you. Don't worry, it doesn't mean you're a bad person. It just means that you really have to pay close attention to what's happening. When you get the absolute value isolated, if the number on the right-hand side is negative, you need to stop because the distance cannot be negative. So the solution is no solution. Does anyone have any questions, comments, or concerns? Okay. Checkpoint number 2. Let's see how you do on your own now. You got 3 minutes. Work efficiently and quickly and accurately. let's see how we're doing now. Part A, what did we get? A little more confidence. Just 3 people were able to answer part A. All right, we got Chris, Michaela, Edgar, and then Kalasia. Chris, what'd you get?
X equals 3 and X equals
Okay, what'd you get, Michaela? Okay, we have a disagreement. I'm sorry, who's next? Edgar, go ahead. You agree with Michaela. What'd you get, Kalasia? Seems to be overwhelming support for that solution, or those 2 solutions, and that is what I was looking for. X is 6, x equals -2. Now, this is not meant to make anybody feel bad, but the person who suggested the other answer would have known that they got the wrong answer if they had checked. If you had plugged your answers in, you would have seen that they don't work. And that would have been a clue that you made a mistake somewhere. Part B, what do we get? Part B. Start with Dalton, Kadir, John, and then Daniela. No solution. Sure? Okay, John? Okay. All of you think no solution? Good, because there's no solution. It took 1 step to figure that out. Part B. You subtract 4 to isolate the absolute value, and then all of a sudden, the right-hand side turned to -1, and then you can stop. You already know that there is no solution. But you must isolate the absolute value first. You will not know until you isolate it. Okay? Comments or questions on checkpoint number 2? Give me a thumbs up if you got both of them right. Good, put your thumbs down. That's pretty good. So now, real-world application of the idea of an absolute value equation is called absolute deviation. And this is used in a lot of different areas in our world, very often in engineering. It has to do with precision. The absolute deviation of a number from a given value is the absolute value of the difference. I'm already confused. I didn't even read the whole thing. But I've basically put it all together just like a formula. But instead of variables, I have some words. So if you want to find an absolute deviation, you take the given value, subtract it from x, and put the absolute value symbol there. And then solve that, and you will get what's called the absolute deviation. So there's a lot of different applications of this idea. It's actually a really simple idea, and some of you are going to find some shortcuts. But right now, I just want to know how to use this formula. So, today's last example is how we're going to use this. The absolute deviation of x from 10 is 1.8. Again, I'm already confused. I find this extremely confusing myself. But if I am just thoughtful about it, and I take out some words, like these words right here, it says the absolute deviation is 1.8. You have to learn how to read things like that. This statement, this part of the statement right here is in the way. You have to learn how to block out the right words to read it correctly. The absolute deviation is 1.8. So where in the formula does the 1.8 go? Where in the formula does it go? John? Well, read the first sentence again with the part that I blocked out. Read it out loud. No, I blocked that part out. Read it as it is. Good. So now read the formula that's in green. I'm sorry, I'm confused. I don't know if you're getting nervous or something, but we read from left to right. Absolute deviation, absolute deviation. Absolute deviation. The absolute deviation is 1.8. Where do you think the 1.8 goes? You then said the given value. But it says the absolute deviation is 1.8. It goes right here. That's why I'm teaching you how to separate the words. So the 1.8 is going to go in place of the absolute deviation. So 1.8 goes on the left. Equals the absolute value of x minus some number. Well, now we need the number. Well, now we have that. So what goes inside the absolute value in that empty space? Nathaniel? 10. So there's only two numbers. The only problem is if you put the numbers in the wrong place, then you're going to get the wrong answer. So you have to really read carefully. This is a reading issue. This is not a math issue. So now we have it set up, and now the rest is easy. You just have to follow the steps. We isolate the absolute value. It's already isolated. Now write it as two equations. X minus 10 equals 1.8. And then the next one is going to be the same thing, except the value will be negative. X minus 10 equals negative 1.8. And now solve both of them, and you get what is called the absolute deviation. The two numbers that tell you how far away from 10 you can go. So here, you get x equals 11.8. That was just mental math. And here you get x equals 8.2. And so those are the two solutions that make this true, or that satisfy this requirement. It's going to seem a little bizarre to you initially, but as you do more and more examples, it will make more and more sense. So that is called absolute deviation. It's actually a very simple application of this idea. Comments, questions, concerns? So I fell a bit behind schedule. That's my fault, not yours. So we will modify the lesson. Everyone will get a free point for classwork. Unfortunately, it is an important part of the process, but we will have to skip it for today. Your homework is page 401, numbers 16 through 36 even, 42 to 48 even, and number 52. None of those questions are optional. They are all required. You need to read the next section. Incredibly important to read the next section. And you have a quiz tomorrow. That will be 6.1 to 6.4.